The battery is a key enabling technology for the transition to a carbon-free society. A battery can store electrical energy that is generated by, for example, solar or wind power, and you can use that energy anytime and anywhere you want. That is why today, batteries are all around us. They are in our cars, our mobile devices, and even powering our households, offices and factories. Most of those batteries are lithium-ion batteries, a battery technology that exists since the 1990s and will remain a dominant battery technology in the near future. Despite continuous efforts to improve safety, lifetime, and performance, traditional lithium-ion batteries are now reaching their limits in terms of energy density, and they suffer from safety issues that become even more critical in the future. Solid-state batteries represent a new type of lithium-ion batteries that can solve these issues. They can carry more energy, and are safer than traditional lithium-ion batteries, because they utilize a solid-state electrolyte, instead of a liquid electrolyte. However, solid-state batteries are not yet manufactured on a large scale. And there is an urgent need for the development of scalable manufacturing technologies. To enable large-scale manufacturing of solid-state batteries, Project PULSELiON sets out pulsed laser deposition and digitalization technologies for solid-state battery manufacturing. PULSELiON is a research project, funded by the European Commission under the Horizon Europe Work Programme. It gathers 15 partners from all over Europe to develop a manufacturing technology for safe and high-performance solid-state batteries. The PULSELiON battery combines a sulfide solid-state electrolyte with a lithium metal anode and a nickel-rich NMC cathode. The main innovation in Project PULSELiON is its pulsed laser deposition technique. This technique will be adapted and modified into a single-step vacuum, roll-to-roll process for manufacturing of the anode and its protective layers, and the sulfide-based electrolyte. The manufacturing of the NMC cathode is based on wet processing techniques, which are optimized by physics-based models. These manufacturing technologies will be upscaled to a manufacturing pilot line proof of concept. This upscaling exercise will be supported by a digital twin that predicts battery performance based on optimization of the manufacturing processes. On the pilot line, 10 Ah solid-state pouch cell batteries will be produced. The 10 Ah prototype cells will reach a remarkably high energy density. They will be able to store 450 to 475 Wh of energy per kilogram battery mass, and 1300 to 1450 Wh of energy per liter battery volume. The cells will also achieve a high lifetime, deteriorating no further than 80% state of health after more than 1500 charge-discharge cycles. Safety testing of these prototypes will demonstrate the increased safety and long-term stability of the PULSELiON batteries during their operational life. While cost modeling will support the demonstration that the PULSELiON manufacturing technology can decrease battery mass production costs to below €75 per kilowatt-hour. Eco-design of the battery production underpins advanced battery life cycle sustainability. And recycling processes will contribute to increasing the critical material recovery rate during recycling to 90%, meeting the EU Battery Directive targets. All in all, Project PULSELiON enables large-scale manufacturing of high-performance and safe, solid-state batteries in a cost-effective and sustainable manner. The PULSELiON project will contribute to the increase of global competitiveness of the European battery ecosystem through delivering breakthrough technologies. At the same time, it will accelerate the application of batteries in mobility and the renewable energy sector due to increased safety, energy, power, and charging performance of batteries, helping to achieve the EU's climate neutrality goals. Would you like to stay informed about the latest PULSELiON news? Please stay tuned via our LinkedIn and X channels. You can also subscribe to our newsletter, or you can reach out to us via email. All information you need can be found on our website www.project-pulselion.eu.